So Gian Paolo Bassi brings more than 25 years experience in 3D and CAD and PLM, and he's been working his way up through Dassault systems, I guess, basically. He was the director, or the vice president of research and development, and he continues that role now as the CEO. He's really setting the future direction and the strategies for the software, as well as the platforms, maybe the cloud and the desktop. Please join me in welcoming to the stage Gian Paolo Bassi.
Thank you, it works. Good morning, everybody. It's always a pleasure to be here. I'm back here again, and thank you for the wonderful introduction. So today I wanted to talk about the future of design, the way we see it. And we believe it has a lot to do with the world of automation. Because we think that the same advances in technology, in computer science, information technology like artificial intelligence, deep learning, the same advances that are bringing to us robots, advanced robots like Baxter, that is designed to interact with humans instead of being completely autonomous, or the same technologies that are bringing to us, for instance, Watson, IBM Watson machine, that has incredible predictive capabilities, is getting closer to the human way of thinking for some type of activities, or the emergence of autonomous vehicles. So we believe that all these advances in technology are going to help tremendously the future of design. But before we discuss with you what we mean and what we see and where are we investing to bring to you the future of design, I would like to pause a moment and meditate a little bit about the concept of automation, because the word automation sometimes brings to mind difficult topics. For instance, the fact that automation may erase some type of jobs, can create occupational issues. So, since we are and we want to be responsible members of the society, I did a little research and I wanted to understand more of what's going on with automation in the society at large. And there is a very interesting research done by the McKinsey Institute that is out there. Everybody can go and check it out. In the last couple of years, they did a lot of research, a lot of interviews. They did a deep dive into the concept of automation. And there are very interesting things that are coming up. And for me, they are painting a very optimistic future. So first of all, the opportunities of automation in manufacturing are still very interesting, about 30%. 30% of opportunities of automation in manufacturing, which is on the low end if compared with every other type of activities or sectors, because, of course, manufacturing has been focused on automation for many, many years. But the most interesting thing is this one. Yes. So the fact that automation is not per se eliminating jobs. It's actually eliminating the nature of the jobs. And for me, this is very interesting. In particular, automation is making obsolete some activities. And the type of activities that are becoming obsolete because of automation are pretty much distributed across a very large spectrum. For instance, in this picture, you see on the x-axis, you see the kind of salary and on the of occupations, of jobs. And on the vertical axis, you see the percentage of time that can be automated. And you can see that there is a very large distribution, including executives. I mean, in some situations, 40% of the activities of executives can be automated. And I can tell you that sometimes it feels like that. I can testify that. So automation is good. But why is it good? It's good because the same research has found out that today, believe it or not, only 4% of the activities performed by people in jobs require creativity, require emotional connection with people. Only 4%. And I'm here to say that we believe that the human brain is designed for exactly this type of activity. So how is that possible that our society is wasting so much potential by using the human brains only in 4% of the occupational activities? So this is why we are excited about automation. We think that automation, and design automation in particular, is here to free the human population to focus on what the human's brain do the best, which is innovate, which is create new things, focus on solving the many problems that we have before us every day. And there are many of them. So we believe that automation will foster innovation. And why do we need innovation? These are the reasons why we need innovation. The problems that the humanity is facing are becoming more and more pressing and more complex. More than half of the human population is living in big cities. How do we reinvent our way of living in big cities? How do we reinvent the way we do transportation? We do education, for instance. How do we do all these things? And companies of any size and any location are under a tremendous pressure to innovate, because the barrier of entry into technology and into business are lowering by the day. So the world is becoming ever more competitive. So we think that the concept of automation is all around what we do today, design, 3D. At the end of the story, we enter the world of 3D not to do pretty pictures, not to translate and project those beautifully computed edges on a piece of paper and spend a lot of time to decorate this piece of paper. For someone else then to interpret those information and do some other interesting job, for instance manufacturing, for instance support, for instance quality management, for instance new innovation, carry over, do new things based on previous thinking. So we think that we started on the right foot many years ago. And today we can say that creating a 3D model is the standard of the industry. And then what? Do we stop here? Do we stop at this beautiful picture on the screen or a beautiful drawing, which is very painful to do, to create, by the way? So we decided that now it is time to fully exploit what we spent a lot of time in creating, the 3D model. And we are becoming a model-based definition-centric company. So we want the 3D model to encompass, as you know, we have been around MBD for a few years now, to encompass, to include every type of information that can make automation happen. And there are many, some of them are indicated here. So model-based definition is very often associated with automation in manufacturing. And you see what we can do today with model-based definition. We can basically attach to a 3D model every information related to the finish, to the tolerances, to the methodologies, to the variation, to the configuration. Everything is there. So we want this everything, every single piece of information, to stay where it belongs, in the 3D format. And this makes it possible amazing things like smart manufacturing. We launched this year, for those of you that came to SOLIDWORKS World or read our news, we have announced a product called SOLIDWORKS CAM. SOLIDWORKS CAM is very intelligent. And the point of us introducing manufacturing is not to add a new product to our portfolio, but is to showcase the potential of integrated design to manufacturing thinking. Is a way of thinking. And in fact, many companies have picked up the hint, and they understand that focusing on the richness of information that today is possible to create with SOLIDWORKS, you can invent a new way of doing things. For instance, I think DriveWorks is in the building today. I think Glenn is in town. So this is a fantastic example of this way of thinking. So you can fully automate configuration to manufacturing without human intervention. Isn't it amazing? And isn't it a way to free up people's time to focus on the future of your products. This is a brake, I think. What about focusing on how to make brakes, drums more efficient, brake disc more efficient? So this capabilities that you see here, which is order, build to order, is a very interesting and shining example of automation thinking. Not only that, there are other ways to exploit the full integration between design and manufacturing, which is one of the drivers of automation. There are many others, but I'm talking about manufacturing right now. For instance, there is this emergency of easy-to-use contract manufacturing outfits out there. I call them the Uber of manufacturing, companies like Fictive, Protolab, Xometry. I believe many of you started using these guys. And those guys have created plugins that install and work directly into SOLIDWORKS because they exploit the design information to do a better job. Let me show an example here, the Xometry. And all those guys right now want to integrate it directly into SOLIDWORKS because they see the opportunity. They see the opportunities to automate the design to manufacturing. In this example, an engineer is trying to manufacture this particular bracket, and the software is advising that with a specific material, a thickness is not sufficient. But if you change material from plastic to aluminum, that thickness could be sufficient. In addition to that, do you want to have tapped holes? Do you want to have a specific type of features? This may change the cost. So there is an intimate connection, an intimate algorithmic approach to manufacturing and to basically advising the designer. This is what we think the future of design is all about. Advising the designer as early as possible in the design phase so that they can make the right decisions in the first place, up front. We believe that the era of design and then simulate and then manufacture, we believe that that era is finished. It's not time anymore to break out your process into pieces, into silos, and communicate among them using a very old and obsolete way of communicating information like paper with notes and decorations that are very costly to produce. So we talked about manufacturing and how automation can benefit that, but can benefit the design, because at the end, we are design-centric. At the end, you innovate, you create value for your customers, where in design, everything else is accessory, right? You have to go from design to the real object, but if you can reduce this distance to zero, the better. If you could prototype very quickly, at the click of a button, if you can go, like Professor Neil Gershenfeld says, from bits to atoms, from digital to real, at the click of a button, I believe that everybody will be much more innovative. Now, the same way of thinking goes throughout the design activities. In fact, we are very proud to introduce this year a technology called design optimization. Design optimization is an algorithm, is a robot, if you will, that takes your design and advises if your design can be optimized, can do the same job with less material. And you can have advice like this. You see the red area against the blue areas, the blue volumes, if you will, and that with in a very fast and quick way, you can adapt your design based on the recommendation of the robot, of your personal advisor. So just like for manufacturing, we believe that the designers today are much more empowered with the smart manufacturing era of products that we are introducing, so that they can make better design decisions with the manufacturing information available and easily usable. Same story for geometry. Geometry can be optimized because at the end of the story, if you create a geometry and then you simulate it, you can have a good answer. Okay, yes, this is not going to break. But the real question is this the best possible geometry to solve a particular problem? And this type of technology will answer exactly that. Just like design, simulate, manufacture in fractured and disconnected silos is in our way of thinking obsolete, same story goes for the next generation of geometries that will exploit advances, for instance, like 3D printing. So you cannot create objects like this using a sketch and extrude approach. This is not going to give you this type of products. So we wanted to introduce an algorithmic approach to the creation of geometry that, for instance, is optimized for 3D printing. And this is an example that we showed also at SOLIDWORKS World. This is a crank of a bicycle, and the opportunity to make it lighter are tremendous if you use technology like this. In this case, we have partnered with Entopology, which is a team of young engineers that are in New York that we believe are the most advanced thinkers in this realm of lattice creation, conformal lattice, or what we call in general algorithmic creation of geometries. In addition to that, we all know that, okay, so this is, all right, so this is the next slide. Similarly, the barriers and the challenges of simulation are rising by the day. We were the first to introduce simulation as a tool in the hands of designers. Again, we are design-centric. All I'm saying here is for designers, is for you. So we were the first to introduce simulation many years back, designed to work for designers, not PhD expert of finite element analysis that needed, to fine-tune the size of the bricks and the formulation and all those very interesting stories that are still very much interesting, but they were confined in a kind of ivory tower, were for the few. Then we wanted to democratize the approach. Now the bar is raising, and we are raising with the bar. And we are very happy to introduce technologies that will let our designers to simulate in the space of non-linear type of problems. And we literally do it at the click of a button. And this is the example. So you do your formulation of the problem, which is basically defining the constraints and the loads and the material, and then you click a button, you have just seen it, and then you go on the cloud where technologies of our sister company Simulia, based on Abacus, which is a world-class solver, will allow you to solve these very complex problems with friction, with the contact situations that, quite frankly, no solver in the world can solve today. Or using material like plastic or rubber, or doing crash tests, drop tests, advanced, that are very, very, very accurate. So, in a way, we wanted to automate and put advanced simulation up front in the design. This is another way that we see automation influencing the way we do design today. Another interesting sector, we can talk a lot about that, is the sector of connected objects. We have many, many customers today that, quite frankly, go to the CES, the Consumer Electronics Show in Vegas, and they win prizes, and they are all our customers. So we started talking to them and trying to understand their best practices. Today, the creation of connected objects is a kind of art. There is no consistent way of doing it. There is no click of a button. We kind of like to do everything at the click of a button. Well, the good news is that we are working on that because the technologies are already in the market. Partners that are already seeing this happening in our space, they reached out to us, company like Xively, for instance. They are already working with you, with customers, with our customers, to create connected objects. Now, we are working very hard to make sure that we can encapsulate these best practices in a product that you can use, and hopefully create your first prototype of a connected object very quickly, very rapidly. And by the way, using also technologies like 3D printing of circuit boards. This is happening, and this is what we are pursuing today. Other things like immersive reality and mixed reality are very important to automate the design because they give you a better perception of what your design is. We are working with many companies. This one here is Meta, a company that is very interesting for augmented reality, but we are working with all of them. We don't have any kind of preferred avenue. Now, Meta is interesting because they do holograms that are touch sensitive. It's the first time. And they are our customers, and they design their device in a holographic situation connected to SolidWorks. We believe that this is a pretty amazing approach, and we wanted to popularize this way of doing a design. We believe that the screen of the future is a goggle. We believe that, and is happening. Other things that are very important and are coming are around the concept of deep learning, the concept of assisted computing, of predictive computing. As you know, we are creating a platform for all of you that you can connect your ideas, your designs, your data, put them on a platform, so that things like products new that you are putting on the market, like conceptual designer or industrial designer, they can exploit capabilities like predictive assembly. So this is an example that is very interesting. Can you imagine putting 5 wheels on this chair? How many clicks do you have to do today? Now, we have a technology based on neural network, which is a derivation of artificial intelligence, that can understand what are the most likely candidates to mating conditions. And they can also understand automatically how many of instances of this product you need. So we can reduce the number of clicks, the number of iterations of interactions by, a factor of 10 or 100. This is pretty interesting. This is coming to you guys, and is not in a not distant future. We talked already about topology optimization, but there are alternative approaches. Topology optimization is about advising on already existing geometry. But what about asking the computer to create geometry for you? This is an example. You don't start from something that you have already designed and then test for optimization. You start from nothing, from zero. You start from the design constraints. What are the loads and where are the possible interaction with the rest of the system, the rest of your apparatus, the rest of your assembly. And then the system comes up with the geometrical advice. You know, we have been running at SolidWorks World for many, many years a competition called Model Mania. And interestingly, the goal was reproduce a drawing in 3D in the most possible efficient way using parametrization. Now, we believe it is time to go beyond this way of thinking. Now, we will create a competition that is not based on reproducing a drawing, but the goal is to create an object, a mechanical object, given objectives and functionalities in the most efficient way. So basically, you can say the same factor of safety with the least material. Today, using sketch and extrude, this is very difficult to do. You need to have very, very skilled designers. I know there are many of you here, but younger and less experienced designer, or even very experienced designer, will benefit a lot from a system that can tell you how geometry could look like to perform your design specifications. And of course, at SolidWorks, we have an amazing environment to test this idea. We have our ecosystem. We work very much with startups. Coming in events like this, it is very exciting for me to talk to young entrepreneurs, or even not so young, but they change the course of their careers. They want to start something new. This is very, very interesting. And these things are happening also inside established companies. They need to do it. So that's why we have a dedicated program for entrepreneurs. And we work very closely to the thinkers and to the people that are excited about innovation, like the Fab Lab Foundation. Fab Labs are all over the world. We are right now helping start Fab Labs in developing countries, because again, we believe that technology and innovation are the best ways to make progress in a society. So the next one is in a small Asian country called Bhutan, which has a very interesting approach to the economy. They don't measure the gross, the GDP, they measure the internal happiness of their people. So we believe they are a fantastic candidate for the next generation of the manufacturing and production systems that are more sustainable and more local. So this is my last slide. I hope that in this brief introduction I showed you what is our thinking about the evolution of what we do for you. This is, by the way, inspired by what you guys are telling us. And we hope that in turn this will inspire your innovation. Thank you very much for your attention.